In this section, we're talking about enthalpy, and enthalpy I've made mention of that in the previous episode, like episode 1 and 2. But you will notice that in those previous episodes, I've been using them interchangeably with energy. So energy is a broad term, and it could mean internal energy, it could mean entropic energy, it could mean enthalpic energy. So to be more specific, we need to specify what kind of energy that we are referring to. And topic energy is one of them, and which is why I want to describe the enthalpy in this episode. So to start with, what is enthalpy? Enthalpy is the heat change that is associated with a reaction at constant pressure. So this is heat change of a reaction at constant pressure, which means you have to keep the pressure of the reaction medium constant, no increase or decrease in pressure. And when we talk about heat change, uh, we represent it as delta H. And this H is representation for enthalpy. Okay, so enthalpy is H, and this delta is a Greek word for change, a Greek letter, sorry, for change. So whenever you see delta H, it means enthalpic change, okay, or heat change. All right, so a typical example of a reaction that we can describe as enthalpic change is a reaction between zinc, solid, copper 2 aqueous to produce copper solid and zinc 2 plus aqueous. The delta H for this reaction is minus 210 kilojoules per mole. So from the previous lesson, we said anything that has a negative delta H sign means it's exothermic reaction. Okay? And we can draw the energy profile diagram for this based on previous explanation. Now, enthalpy is a state function. Okay? So note that. Enthalpy is a state function, which means that it does not depend on the direction by which the reaction follows, or it does not depend on the history of chemical paths that the reaction takes. Okay, so and we said that the delta H here is negative. We can represent this on a reaction profile diagram just to remind ourselves of how to do that. Okay, so if we have straight line, this is the reaction, this is the reaction coordinate, and this is H, the enthalpy. Okay, so in this case we'll have a reaction profile diagram to look like this, where we'll have a zinc solid plus copper 2 plus aqueous, and then we have a copper 2 plus, and we have a copper solid plus zinc 2 plus aqueous. So if we check the relative energy of the reactant and the product, so this is the reactant and this is the product, the difference between the two will give us the delta H of reaction, and this is minus 210 kilojoules per mole. Okay, so that is an example of the energy profile for a typical for typical exothermic reaction that has a negative enthalpy of reaction. So, key things to remember. Okay, just like a summary. Now we'll talk about this better in the next episode. Enthalpy is its change at constant pressure. Pressure has capital P. Entropy change is represented as delta H. Okay, and enthalpy is a state function. That is, it does not depend on the history of the chemical taking part in the reaction. For enthalpy change, or delta H, of positive is endothermic, and enthalpy change of negative is exothermic. Alright, so that is that for this video. One thing that you should remember to do is to hit the subscribe button, and also you can send me an email at chemistry-knowledge-hub@gmail.com if you have any question or need help with doing or providing solution to an assignment problem. Okay. You can also find this email on the about description button or the about to section on this YouTube video.